Hey grade 6. In the last video I recorded, we went through, checking on a thing. In the last video I recorded, we went through a bunch of, we went through the steps to do the candle in a jar experiment, but I was trying to show a whole lot of restraint in the actual explanation of it. That's because I want you to discover these things for yourself whenever possible. But because you also need to know these things and you need the correct explanation in case you didn't come up with that, this is what's actually happening. This is going to be my explainer for the experiment. I'm going to do it live one more time, but I'm going to talk you through what's happening. So, let's get started. Once again, I've got my control candle, my candle that is outside of the jar, and we can observe without it. I'll just do this. The candle that's outside of the jar, and we can observe as a control. In science, control means the one that you're not changing. It's our baseline for observations. Because we have one that we're not doing anything to, when we make a change here, we know that anything that we see that's happening that's different is because of our change. A control lets us have a basis for that. So, let's light both candles. Got my little fire stick again. Alright, here we go. So we'll light our control. There we go. And we will light our experimental candle, the one that we're actually going to do something to. Or we will try to light our experimental candle. Come on. Did the wick take? The wick has taken. Alright, good. Now that both candles are lit, I'm going to move this so that I'm not talking over it. Now that both candles are lit, we are able to see that the control and experimental candles have pretty much no difference. Now, something that we talked about in class was that our air is made up of primarily two elements. It is 78% nitrogen and 21% oxygen. Now, that still leaves 1%. That only makes a total of 99. That last 1% is made up of a whole lot of different gases. Argon, neon, carbon dioxide, all of those things that you know are in our atmosphere but aren't enough to really matter for our purposes. Now, for fire to burn, it needs two things. It needs carbon from the thing that is burning and oxygen from the air. Now, as oxygen and carbon react in this exothermic reaction, carbon dioxide is created that replaces the oxygen in the air. So these candles, as something burns, they actually release a small amount of carbon dioxide. As the carbon molecules from the thing that is burning get used up, get combined with the oxygen from the air, and both the carbon and oxygen no longer exist by themselves, instead, it turns into carbon dioxide. So when I seal this jar, I'm trapping the air that's in the jar, and there's nothing else that's going to be added to it. It's not able to get more oxygen from the air around it. So when I put the seal on, this jar now contains nitrogen, oxygen, a flame, and some carbon to burn up. This candle, our control candle, is still getting all of the oxygen from the air, and this room has a lot more oxygen in it than this jar does. As you see the candle getting weaker, the oxygen in the jar is starting to be used up. It's being turned into carbon dioxide as it bonds with the carbon from the wick and the wax. Eventually, there's not going to be enough oxygen left in this jar for the candle to stay lit. So as the flame dies, it's almost gone now. Still lit, there'll be a little puff of smoke when it's done. I don't know if that'll show up on camera. As the flame dies, there's our smoke puff. As the flame dies, there's not enough oxygen left in this jar to sustain the flame. This jar now contains, percentage-wise, much more nitrogen than it does oxygen or any other gas. This jar is largely nitrogen at this point. When I open it up, oxygen will start to flood back in and it'll remix and everything will be the way it was before. But for right now, I basically just have a jar of nitrogen with a trace amount of other things. And a fair amount of carbon dioxide compared to what was in there before. So if I open up the jar again, Now it's hard to tell because there's nothing to observe a difference in with the candle out. But if I open up the jar again, there will be oxygen flooding back into it. It will stabilize and kind of reach a balance with the rest of the air in this room. Which is why in our second demonstration, where I opened up the jar again before the candle was fully out, it relit itself. Let's do that one more time. I've got my candle. We're going to light it. Our control is still lit because that's what controls do. They stay stable. And still not lit. Great. These are cheap Amazon candles. They are not fantastic, but hopefully we can get a constant flame on here. There we go. Okay. Our candle's lit again. Now you'll notice, hopefully, again, fire doesn't show up on camera super well because it's basically just pure light and that confuses cameras. But hopefully you can tell from the camera that this candle and this candle are about equally strong flames right now. So we'll seal up this jar again. And we'll let some of that oxygen get used up, but not all of it. We're going to leave enough oxygen for the candle to stay lit. It's just going to be quite weak by the time we open the jar up again. So right now we've got a jar with the same balance of chemicals, the same balance of molecules that our air normally has, and a candle that's just exposed to that same air. As we close this, some of the oxygen is going to get used up, and that flame is going to get weaker and weaker. Now we're going to let it get down so far that just a little bit of the blue flame on the outside, not the orange, is going to stay lit. So it's going to get very weak and almost all the way out. And then we're going to open it up and let the jar reach equilibrium with the room again. There we go. That's open. And we're lit again. Still weak, but getting stronger as the air comes in. It takes time to mix. It doesn't happen right away. But even as I was saying that sentence, it seems to balance out. And we're right back to the control candle again. So between these two, we can see not just something about the gas composition of our atmosphere, the chemicals in our atmosphere. We can also see just a fact about gases. And that is that when you have an open container, gases inside of that container will try to reach a balance with the space around it. This is why opening a door in outer space is a bad idea, because you have enough gas inside your spaceship or a space station to keep you alive. You have enough oxygen, you have enough atmosphere in there. But if you open the door, it's going to try and balance with the rest of the universe, which is empty. And pretty soon, those molecules will be spread so far that you will suffocate. If you don't die for another reason first. There are a lot of ways space can kill you. So this is a smaller version of that. The gases inside the jar were their own mix that was different after it had been sealed for a while than the atmosphere around it. As we open the jar, the gases inside and outside the jar flowed into each other to try to equalize, to try to balance each other out, and we could see the flame getting stronger as they achieved that goal. All right, let's put these out. I said, there we go. And that'll do it for today. That's our explanation. So I hope that was illuminating for you. But Tish, there will be more experiments throughout the year. We're just getting started here. I'm going to be putting up a lot of these as we continue through our air and flight units, because there's a lot of things to experiment on and demonstrate. Hopefully you're able to do more of them at home than by watching me, but I'm here for you all year. All right, guys, that's it. Peace.